All right, so absolute value inequality. So remember the same steps kind of like before, right? All right, so here I want to make sure that there's no numbers on the outside or inside. And if you notice with all of these problems, they don't have a number on the outside. So you don't have to worry about that with these ones, okay? So the only thing we're going to do is we're going to split it. Okay, so we're going to split these into two. Now, when you split it, you're not going to write the inequality. You're only going to write the equation. So instead of writing less than or equal, we're just going to write equal to or just equal, and then 4. And then remember the second equation is the same thing, but we just changed that second number to a negative. Okay. All right, so now we're going to solve each of these. So first, we're going to add 9 here on both sides. And on the second equation as well. That cancels. We have x equals 13. And then that cancels, and we have x equals -4 plus 9. That's going to be 5. Okay. Now, I want you to know how to write the answer to this question in 2 different ways, both by graphing it, but also by writing the statement. Okay. So the first part is we're going to do a number line. Now, when you draw your number line, what's important is make sure that you put your largest number first, right? Just because the 13 is here doesn't mean I put 13 right under it, right? That's bigger than 5. So when I write this out, I want 13 over here and 5 over here. And then you can always put like a 0 in the middle if you want, okay? Now, I need a circle on each number, right? So I go back to the sign, and remember that if I have these, if I have equal to, it's going to be a closed dot. And actually, I'm going to do that in blue. Okay, and if it is, I'm going to do these actually in highlighter blue. And then if it's just less than or greater than, you're going to do an open dot. Okay, so for this case, it would be 2 closed dots, but I'm not going to shade just yet. What I need to do is test a number, okay? You just need to pick a number inside or outside. It doesn't matter where you start. You only need one number to test. And honestly, the easiest thing I always say to do is just use 0. Just plug in 0 because that's gonna, that'll work for every problem you do. All right, so here, I'm gonna do the test. All right, and I'm gonna take that 0 and plug it into the equation, into the inequality. So 0 minus 9 is less than or equal to 4. And now I just simplify it and see if it's true or not true. So 0 minus 9, that's -9, or the absolute value of -9. And then I take the absolute value of -9, which remember, everything is the absolute value always is what? What do you guys think? It's going to be positive. So -9 will be +9. Okay, so 9 is, so what it says is 9 is, let me focus this for you guys on. Okay, it says 9 is less than or equal to 4. Is 9 less than 4? No, it's not. So that's not true. Okay, so not true. If it's not true, so remember what that number I picked was inside between the circles, right? So what that means is that none of the numbers in the middle are the part of the solution. That means your solutions are on the outside of those circles. So that means it's to the right and to the left. Okay, so that means I've got 2 separate areas for my solution. So when I write the statement, especially this is what you're going to need to know for Deltamath, is I'm going to write 2 separate statements. The first one, I'm going to start with that number, and it says x is, well, if it's going to the left, is that less than or greater than? That's less. So I would go x is less than. Do I put the equal sign? Yeah, because it's a closed circle. So it's less than or equal to 5. Now, because there's this gap in the middle, I would put or, okay, put or, x is, what would it be here? Greater than or equal, okay, because we have that, again, that closed dot. So that ends up being my final answer right there, okay? Now, for the purpose of Deltamath, you need to know how to do this one, okay? So let me write that here. This is for Deltamath. So as you guys are working through those problems, that's how you answer it, all right? When you look at the example online, it'll show you the graph, but what they want you to do is type this right here. All they want is that. Okay, so but once you type your graph, if you got them going both different directions, you know it's going to be an or. All right, it's going to be like one inequality or another. Okay. All right, let's move that up a little bit. All right, zoom out just a tad. Okay. All right, so now the second one. Again, remember there's no, I should write that in the notes here. Split. Okay, we split here because the, let's say we'll put like, trying to write this as simply as possible. Because x minus 9, the absolute value of x minus 9 is isolated. So right there. Again, the reason we split it, we didn't have to do anything else, was because that's by itself. And again, the same thing is here, right? This is isolated, so we're going to split right now into 2. So remember, the first one, I just literally repeat the exact same numbers, and I'm going to put equal instead of the inequality sign. And then the second one, repeat it again, just make that last number negative. Okay, then go ahead and solve that. So minus 6 and minus 6, that equals 1. And here again, minus 6, but now it's negative 6 minus 6, and that's negative 13. So again, I'm going to make my number line. And remember, which number is larger, 1 or negative 13? 1. 1 is, right? Because negatives are smaller or less value. So the 0 is probably a little bit closer to 1, so I'll put the 0 right there. Move this down a little bit. All right, now, what kind of circles? We got open or closed? They're open, so put open over those values. And now we got to do the test point. Okay, so again, I always like to use 0. It's the easiest thing to plug in. So I'm just going to take that 0, plug it in, and see if it's true. So 0 plus 6 is greater than 7. So I'm basically just repeating that and plugging in the 0. And here, let's actually make a note of that. So plug in any number. But again, I like to plug in 0. All right, so 0 plus 6, that's absolute value of 6. Absolute value of 6 is 6. And the question is that greater than or is that less than? That's less. That is, should say less than, right? So again, it's another one that's not true. So if it's not true in the middle, again, I'm out here and out here with the shade on the graph. And then the answer I'm looking for is x is now less than minus 13 or x is greater than 1. Okay, so that's another case where, again, you're going to have an or. Okay, so let's just say you're plugging in your answer on Deltamath. Let's say this one here. All right, let's say I work through, actually, let's go, sorry, we'll go down here. Let's go to my side of things so we can kind of see how it goes. right, so I'm working on this one, and I find that the answer is, let's see, I would add 9 the first time, so I get 17. And then the other number would be -6 plus 7, so that'd be 1. So 1 and 17, if I plugged in 0, 9 is greater. So in this case, I would put 1 slash x, and is x is greater than 1 and less than 17. Now, for the case like that I just showed you, you would literally just type it just how I wrote it. So it put like x is less than 13, and then there's an or button. I think you can just type it. And then you put your next solution or next part of the inequality, just like that. So you literally just type the first one. You can type or you can just hit the or button and then put x is greater than 1. Okay, so that's how you write it out when they're separate. All right, so let's take a look at another case here. So let's go with, I think I'm going to change up this third one because I would like to have a different type of problem. So just give me a second here. Okay, so now x minus 5 less than 10. Okay, again, everything's isolated. Let's split it. I have x minus 5 equals 10. And then x minus 5 equals -10. Or that next second number switches. Add 5 both sides for both equations. Those 5's cancel. And the first one, x equals 10 plus 5, 15. The second one is -10 plus 5, which is -5. Create my number line. Remember, the larger number goes output to the right, 15. Smaller value over here to the left. Go ahead and throw in a 0 there. And now we'll test it out. So now I'm going to plug in that 0. Oh, actually, before that, let's go ahead and put our circles in there. Now remember that I've got less than. Remember, less than will be an open circle. So open. And now we'll test. Okay, so now I'm going to take 0 again and plug it in. -5, less than 10. So 0 minus 5, -5. That is not the result that I wanted on this problem. Did I write something down wrong? I feel like I wrote something down wrong. Okay, so the absolute value of 5, is that less than 10? Oh, no, this actually is the one I want. Sorry. Okay, so absolute value of -5 is 5, and then 5 is less than 10. That, in this case, is true. All right, so this is the one case where it is true. So if I picked a number, if my number that I picked is true, that means that area is where the solution is at. So now the solution is in between the two numbers. It's both the solution, the answers could be bigger than -5, but it could also be less than 15. And now the way we write this out is instead of saying or, because we say or because they're going different ways, but now they're together. So on the left, I put the lower number, -5. On the right, I put 15, just like you see on the number line. In the middle, where x is the solution, I put x. And then on the sides here, I put less than and less than, just like that. Because the answer is both bigger than -5, but it's also less than -15. And just make sure that your inequalities match your inequality here. So if it doesn't have the equal sign, make sure you put that there as well. Okay, so that again is what you would enter in Deltamath. All right, if you have the solutions in between the two numbers. All right. All right, for this last one, I'm gonna just change this just to equal to. So this is x plus 3 less than or equal to 13. So one more. So again, split it. Equals 13. x plus 3 equals negative 13. I'm going to subtract 3 from both sides, here and there. I get 10, x equals 10. Here I get negative 13 minus 3, negative 16. And again, I put those two numbers on the number line. So negative 16 is smaller and 10 is larger. I'll put 0 somewhere here in the middle. In this case, I've got equal to. So I'll put closed circles on my number line. And then now it's time to test once I have this. And again, you can always test 0. You can pick any number you want. So I'll do 0 plus 3 is less than or equal to 13. And then go ahead and simplify that. 0 plus 3 is 3. Absolute value of 3 is 3. And the question is 3 less than or equal to 13? It is. So again, another case where it's true. And because the number in between the two is true, I would shade in here. And now I write it pretty much the exact way I did up here. Okay, so here, negative 16 and 10, the solution is between the two, but the only difference this time is now that it's going to be less than or equal just because I'm using the same sign. Yes, so you want your larger value to the right and your negative value to the left. Now, technically, you could switch it, but that means you also got to switch your sign. Because you got to make sure that it says that x is less than the 10. So technically, this could be written this way too. If I write it like that, I just got to make sure that the signs say that x is less than the 10. And basically, I'm just switching them. That means the same thing. For simplicity's sake, I just copy down from the number line. Okay. Okay, so again, guys, for Deltamath, that's the expectation of what the solution should look like, or what your inequality should look like. Just trying to zoom out so you can see the whole thing, in case you guys need to copy anything. But this is more so for practice and to be able to kind of see where your solution is. You just have to remember that whatever number you pick, which in this case I picked 0 every time, I could have picked like 12 or something less than 16. And if I had picked, let's say 15, right? Would it have been true or not true for this problem? If I picked 15, would I have gotten a false answer or a true? Because if the solution's here, can the solution be bigger than 10? It'd be false. Because if the 0 works, if I plug in 0 and it's true, if I take any number outside here, bigger than 10 or less than 16, I would get a false answer. And then that's when I would know I would shade here. Just like here, remember I picked 0 and it did not work. So if it doesn't work, I don't shade the area where that number was. I shade the opposite of it. Okay? All right, let me stop